You're listening to DTFHN for April 14th, 2026. I'm your trust but verified host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where mass paranoia occasionally qualifies as engineering wisdom. Today's got that beautiful tension between what systems promise and what they actually do when nobody's watching. Let's crack it open. One commenter put it perfectly. They'd been editing stills inside Resolve for years, just waiting for this day to come. And honestly, if you've ever used Resolve's color tools on video and then switched to Lightroom for photos, you know exactly what they mean. It's like going from a concert grand piano back to a keyboard with sticky keys. Let's pull this thread because what Blackmagic just did with DaVinci Resolve Photo is a masterclass in what I'd call architectural inheritance. A concept borrowed from biology. When an organism evolves a complex structure for one purpose, sometimes that structure turns out to be pre-adapted for something entirely different. Feathers evolved for thermoregulation, then enabled flight. Resolve's color science evolved for cinema-grade video, grading. Node-based color pipelines, HDR tone mapping, perceptual color models. And now those same tools just landed in the world of still photography, and the results are frankly embarrassing for the incumbent. The technical depth here deserves real appreciation. Resolve's color page already handles wide gamut workflows. DaVinci's proprietary color space mapping and power windows with tracking. Tools that photo editors have been slowly, painfully reinventing for years. Native RAW support for Canon, Fujifilm, Nikon, Sony, and iPhone Pro. Non-destructive grade versioning that references the original source file. No duplicates, no bloat. Node-based grading that lets you build reusable color pipelines. One commenter had to dig to even find the raw support specs, which tells you Blackmagic is underselling this. Now the business model question came up in the comments, and it's worth addressing. Blackmagic gives away what is arguably the most powerful post-production suite on the planet. Free. The paid studio version exists, but the free tier is absurdly capable. They make their money on hardware. Cameras, capture cars, switching gear, the software's the razor blade handle, and this is where the craft deserves admiration, because they've built something that competes with $1,000 software ecosystems, and they hand it to you for nothing, because it makes their hardware ecosystem stickier. One frustration that came up? Linux support. Resolve technically runs on Linux, but the experience is rough. Several commenters flagged it. For a tool this powerful, that gap matters, especially for the kind of technical users who'd push it hardest. But step back and look at what happened here. A company took a decade of cinema-grade color science, recognized it was already 90% of the way to a world-class photo editor, and shipped the remaining 10%. That's not a pivot. That's an exaptation. The engineering was already there, waiting to be recognized for what it could become. That's how great tools evolve. Moving on. In Labo, the Jet Propulsion Laboratory discovered that magnetic tapes containing Viking Mars mission data were degrading. The backup system had been running for years. Nobody had checked whether the tapes were still readable. They weren't. Entire data sets from the surface of Mars gone, while a backup system hummed along reporting that everything was fine. Backblaze just did the same thing, except on purpose. Here's the question nobody in that Reddit thread is asking. If Backblaze can silently remove OneDrive folders, Dropbox folders, and .git directories from your backup without surfacing a single notification, without updating the exclusions list in their own preferences panel, without sending an email. What else have they removed that you haven't noticed yet? A user named Reese found out the hard way. 10 years of trusting Backblaze. A force push accident wipes Git history on a repo. No problem. Restore from backup. Except, Backblaze had quietly decided .git folders weren't worth storing anymore. No changelog entry. No preference toggle. Just gone. Then a Reddit thread services. Dropbox folders excluded. OneDrive folders excluded. A decade-long customer logs in and discovers an entire Cloud Sync directory simply missing from the backup. The deadpan comedy here is exquisite. Backblaze's entire pitch is we back up everything on your computer. That's the product. That's the one sentence on the tin. And they've been quietly shrinking the definition of everything while continuing to charge the same price for a service that now does demonstrably less. And the predictable response, well, OneDrive already backs up those files, reveals a fundamental misunderstanding that Backblaze, a backup company, should know better than anyone. Sync is not backup. OneDrive keeps deleted files for 30 days. Backblaze offers a year, or unlimited if you pay. Those are categorically different promises. A sync service protects you from your hard drive dying. A backup service protects you from yourself, from ransomware, from the sync service itself corrupting data. Collapsing those two concepts is malpractice from a company whose entire existence depends on people understanding the difference. One commenter nailed it. Some companies are in the business of trust. Trust is difficult to earn, easy to lose, and nearly impossible to regain. This is what happens when the incentive function of an unlimited storage provider quietly shifts from back up everything to back up everything that doesn't cost us too much. The business model is the architecture. And when the business model says unlimited, but the engineering says actually let's trim the expensive bit, you don't have a backup service anymore. You have a service that looks like backup until the moment you need it. The tools to verify this exist. Check your backup inventory tonight, because the system is still humming along, reporting everything is fine. Systems that quietly misbehave when you're not looking. So let's talk about the web version of that. Story 3. Every browser ships with a contract. You click forward, you go forward, you click back, you go back. It's one of the oldest interaction patterns on the web. So fundamental that most people never think about it, which is exactly why it became a target. Back button hijacking is a technique where a site injects fake entries into your browser history. So when you hit back, you don't return to where you came from. You land on an ad page, a recommendation wall, some page you never visited. The site has quietly rewritten your navigation stack to keep you trapped in its funnel. And Google just announced they're making this an explicit spam policy violation, with enforcement starting June 15th. Let's pull this thread on the technical side, because the engineering here is worth understanding. The history API. Push state and replace state was designed to let single-page applications manage navigation without full-page reloads. Legitimate, useful, elegant. But the same API that lets a well-built app update the URL bar as you scroll through content also lets a bad actor stuff your history with entries that redirect back to their own pages. The browser can't distinguish intent. It faithfully records whatever the page tells it to record. This is a textbook case of API design meeting adversarial incentives. The feature works exactly as specified. The abuse works exactly as specified too. And one of the commenters points out something critical. A lot of this hijacking doesn't even come from the site owner. It comes from third-party ad scripts and tracking libraries they've embedded. You include someone else's JavaScript. You inherit their ethics. The site owner may not even know their back button is broken. Google, framing this as a spam violation rather than a browser-level fix, is revealing. They could lobby for browser API restrictions. They could push for a spec change that limits history manipulation. Instead, they're using search ranking as the enforcement mechanism, which works, but only within Google's ecosystem. The open web doesn't have a single referee, and that's by design. The real fix lives in the browser itself, in giving users a history stack they can trust, because the architecture guarantees it, not because a search engine threatens demotion. 2 months notice before enforcement. Plenty of time for site owners to audit their ad script. And that audit alone might be the most valuable part of this whole policy. Sometimes you don't know what's running on your own site until someone forces you to look. And if not knowing what's running on your own site sounds bad, wait until the code you trusted gets sold to someone you shouldn't. What does trust actually cost in a software ecosystem where anyone can buy it for 6 figures on Flippa? A developer team in India spent nearly a decade building 30-plus WordPress plugins. Legitimate tools, real users, earned reputation. Revenue declined. They listed the portfolio for sale. Someone bought it. And then, 8 months later, over 30 plugins started phoning home to a command and control server that resolved its domain through an Ethereum smart contract. Let me be precise about what happened technically, because the sophistication matters. Version 2.6.7 of Countdown Timer Ultimate shipped in August 2025 with a changelog that read, "Check compatibility with WordPress version 6.8.2. What it actually contained was a PHP deserialization backdoor, a fetch method that pulls arbitrary data from a remote server, unserializes it, and executes whatever function the server specifies with whatever arguments the server provides. Permission callback set to return true. No authentication required. 191 lines of code added to a file, sitting dormant for 8 months before activation. When it finally fired, it injected spam into wp-config.php that only rendered for Googlebot. Site owners saw nothing. The blockchain-based domain resolution meant traditional takedowns were useless. The attacker could rotate infrastructure by updating a smart contract. Now here is where I want to argue the uncomfortable position. You could look at this and say the problem is that plugin sales should be prohibited. One commenter made exactly that case. But consider, the original developers built something valuable. Revenue dropped nearly half, and selling was their exit. Prohibiting sales doesn't eliminate the incentive for supply chain attack. It just eliminates the legitimate marketplace, pushing acquisitions into less transparent channels. The attack surface isn't commerce. It's blind trust in automatic updates from unaudited code. WordPress.org force-pushed a clean version of the plugin. It did not touch wp-config.php. The investigator found the infection window using binary search across 8 backup snapshots. 6-hour and 44-minute gap between clean and compromised. That forensic work, documented publicly, shared freely, is the actual defense model. One security researcher with good backups and the willingness to publish methodology did more to protect the ecosystem than any proprietary scanning service. The tools that caught this were open. The backups were open. The write-up was open. The attack succeeded precisely where things were closed. Where code review didn't happen, where update trust was automatic, where a transaction transferred reputation without transferring accountability. This one is genuinely wild, and it might reshape how we think about language model inference entirely. Let me make the strongest case for why diffusion language models are a dead end. Autoregressive decoding works. It scales. Every major frontier model ships with it. The entire inference stack, from KV caches to speculative decoding to SGLang, is built around predicting one token after another. Diffusion models for text have been a research curiosity for years now, consistently underperforming, requiring custom infrastructure, burning extra compute for worse results. The pragmatic position is simple. Stop trying to make parallel text generation happen. Now let me explain why that pragmatic position just collapsed. A team just released IDLM, Introspective Diffusion Language Models, and the results are not incremental. They took a standard Ketwin autoregressive model, an 8 billion parameter checkpoint, sitting on Hugging Face, and converted it into a diffusion model that matches the original on quality. Not close to matching. Matching. 69.6 on AIM24, which is a competitive math benchmark, versus 43.3 from Alatoin, the previous best diffusion model at twice the parameter count. Let's be precise about what happened here. They didn't train a new architecture from scratch. They didn't need 100 billion parameters to compensate. They identified the actual bottleneck, fixed it, and got parity at the same scale. The bottleneck is what they call introspective consistency, and breaking it down to first principles makes the fix obvious in hindsight. When an autoregressive model generates token 5, it is already committed to tokens 1 through 4. Generation and verification happen in the same forward pass. Diffusion models don't get this for free. They learn to denoise, to go from noise toward plausible text, but they never learn to check their own work mid-generation. The IDLM fix is elegant. Each forward pass generates new tokens while simultaneously verifying the ones it already placed. If a token doesn't pass an acceptance criterion, it gets regenerated. The model introspects. The throughput numbers matter as much as the quality numbers. 2.9 to 4.1 times faster than OLI AA at high concurrency, using standard AR serving infrastructure. No custom kernels. No exotic scheduling. It drops into SGLAA because they kept causal attention, which means every optimization the open source inference community has built over the past 2 years just works. One commenter nailed the implication. They converted an autoregressor into a diffuser using clever techniques and vastly outperformed every native diffusion model. The weights are on Hugging Face. The code is released. The method works on both 8 and 32 billion parameter scales. This is what happens when the research is open, and the weights are public. Someone identifies a theoretical gap, publishes the fix, and the entire community can build on it tomorrow. The closed labs can't move this fast because they can't leverage 1,000 external engineers iterating on their checkpoints. The bootstrap works. Remember when we talked about tools that just get out of your way? GitHub's finally fixing one of the oldest developer workflow pain points. I once spent 3 days reviewing a single pull request, 1,400 lines across 22 files. By the end, I was rubber stamping functions I barely understood, because my brain had burned through its capacity for careful attention somewhere around file 9. That PR shipped a bug that took a week to find. The review process didn't fail because the reviewer was lazy. It failed because the tool demanded something humans can't do. Hold 1,400 lines of context in working memory while evaluating correctness. GitHub just shipped native support for stacked pull requests, and this matters more than it sounds. In Yuyan Joadyan Minlenas Torvalds started sending kernel patches to the mailing list. The convention was small atomic changes. One patch, one logical unit. Reviewers could hold the entire change in their head. The Linux kernel scaled to 30 million lines of code. Not despite this discipline, but because of it. Somewhere along the way, GitHub's pull request model drifted from that principle. A branch became a bucket. Developers accumulated commits until the diff was massive. then ask the colleague to make sense of it all at once. Stacked PRs. Bring back the atomic unit. You break a large change into layers. Authentication first, then API routes, then the front end. Each one a separate pull request that builds on the one below it. Reviewers see focused diffs. CI runs against each layer independently, and when you're ready, the whole stack merges together or through the merge queue. The CLI is clean. GS init, GS add, GS push, GS submit. 4 commands to go from idea to a reviewable stack. The GitHub UI shows a map of the stack so reviewers can navigate between layers. Branch protection enforces against the final target, not the intermediate bases. After any merge, remaining PRs automatically rebase. The commenters who've used Fabricator or Gerrit are feeling vindicated right now, and they should. This workflow existed for years in tools that never reached critical mass, because they weren't where the code already lived. GitHub building this natively means the largest developer platform on Earth just made better code review the path of least resistance. The tooling is open. The extension installs with one command. Your AI coding agents can learn the workflow through a skills integration. This is infrastructure for how collaborative development should actually work. Small, reviewable, atomic changes that respect the limits of human attention. The way patches were always meant to be. Remember when we talked about running models on your own hardware? Same energy, different layer. Pause. Let's talk distributed DuckDB. 2 RPCs. The entire protocol that makes OpenDuck work is defined in a single protobuf file with 2 remote procedure calls. 1 to execute a query, 1 to stream results back as arrow IPC batches. That's the whole contract between your laptop and the cloud. This matters more than it sounds. MotherDuck proved something genuinely elegant. That DuckDB could split a query plan across local and remote machines, scanning your laptop's tables on your laptop and cloud tables on cloud workers, then stitching the results together with bridge operators at the boundaries. You write one SQL statement. The system figures out where each piece runs. Only intermediate results cross the wire. It's beautiful engineering, and it was locked behind a proprietary service. OpenDuck takes the architecture apart and rebuilds it in the open. The gateway is Rust. Storage is append-only immutable layers backed by any object store, with PostgreSQL tracking the metadata. DuckDB's own catalog interfaces get implemented directly. Remote tables aren't some shimmed abstraction. They're first-class catalog entries that participate in joins, CTEs, and the query optimizer like anything local. The extension speaks DuckDB's native storage extension, API. This isn't a wrapper. It's a peer. But come back to those 2 RPCs. Because the protocol is that minimal, any service that speaks gRPC and returns arrow can serve as a backend. Swap the Rust gateway for your own. Plug in a completely different execution engine. The client extension doesn't care what answers the phone. That's what an open protocol actually means. Not documentation you can read, but a surface so small that re-implementation is trivial. One of the commenters noted this looks like one-shot AI output replicating a SaaS product. Maybe, but the architectural decisions are sound, and the code exists where anyone can fork it. The interesting detail isn't who wrote it or how fast. It's that the idea's MotherDuck validated. Differential storage, hybrid execution, the attach and go UX are now building blocks anyone can pick up. The ladder is down. The runs are labeled. Climb. But what happens when the spirit of the clone gets truly unhinged? Story 8. Franklin's magnificent bad ads. Ralph Archbold made a living being Benjamin Franklin, not playing him, being him, the city of Philadelphia's official Franklin impersonator, married to the official Betsy Ross impersonator, face plastered across every tourism brochure in the Delaware Valley. And sometime around 1982, he showed up in an ad for a computer company called Franklin, selling a machine called the Ace 1000, which was down to the chip arrangement on the motherboard, an Apple II. Follow the chain of copies. Apple runs an ad showing Ben Franklin designing his kite experiment on an Apple II. A company named Franklin builds a clone of that exact computer. They hire a professional Ben Franklin impersonator from the city Ben Franklin actually lived in, which happens to be 12 miles from their headquarters in Pennsauken, New Jersey. Then they trademark a cartoon version of Ben Franklin and print it in every user manual. The layers of appropriation are so dense, they become their own art form. Steve Wozniak reportedly opened an Ace 1000 and found his own circuit board layout staring back at him. The reviewer who documented this could pull Apple cards out of one machine and slot them into the other. Franklin's engineers, one of whom was literally named Bob Applegate, were building these things so fast they shipped the first model in an off-the-shelf case, because waiting for a custom enclosure would have cost months they didn't have. Here's the thing. The original article won't say Franklin was doing what every interesting technology company does. They took something that worked, made it cheaper, and put it in more hands. The Ace 1000 retailed for less than the Apple II. Same software compatibility, same expansion slots, more people computing. That's not a crime against innovation. That's innovation working exactly as intended. Apple's legal victory over Franklin in 1983 established that operating system code could be copyrighted. Run that forward. That precedent didn't protect creators. It protected margins. It built the legal scaffolding for every software lock-in strategy that followed. One company's circuit board layout became the justification for decades of closed systems. The cops got called on Franklin's booth models at Applefest '82. The courts shut down their clones a year later. Ralph Archbold kept being Ben Franklin. The kite was already in the air. We talked earlier about trusting the machine. Well, pause. Here's a beautiful case of trusting the machine too much. The top comment on this one cuts right through the headline. Quote, clickbait title. The proved part of the program had no bugs. And they're right. That's actually the more interesting story. Kieran pointed a Claude agent armed with AFL++, address sanitizer, and Valgrind at lean zip. A formally verified implementation of Zeebly built by 10 autonomous agents and proven correct in lean. Over 105 million fuzzing executions. What did she find? A buffer overflow in the lean runtime. Not in the verified code, in the infrastructure. Underneath it. Let me describe why this result is beautiful. The theorem says, for any byte array under a gigabyte, decompressing the compressed output returns the original data. Lean's type system guarantees this at the mathematical level, and the fuzzer confirmed it. 100 million inputs, 0 violations of the proven properties. The proof held, the craft held. But the program still had a bug, too. Because formal verification proves properties about a model of computation, and that model runs on actual metal through an actual runtime compiled by an actual compiler. The lean runtime had a buffer overflow in its byte array reallocation logic. The proof was airtight. The floor underneath it wasn't. Now, run this forward 5 years. Formal verification tools are getting dramatically more accessible. 10 agents built and proved a Zeebly implementation autonomously. Meanwhile, vulnerability discovery costs are collapsing. Every piece of software is about to face scrutiny it was never designed for. These two trends are on a collision course, and this result shows us exactly where the fault line sits. The verified layers survived. The unverified layers didn't. The answer isn't to distrust formal verification. It's to extend it downward. Verify the runtime. Verify the compiler. Push the trusted computing base smaller and smaller until there's nowhere left for bugs to hide. One commenter nailed the distributed systems parallel. The proof holds inside an operating envelope. Trusted runtime, bounded sizes, no adversarial inputs at the boundary. Every assumption you don't prove is a surface you don't protect. The elegant part is that lean is open. The proof is on GitHub. The runtime bug got found because anyone could point a fuzzer at it. A closed verification system with a proprietary runtime would have shipped that buffer overflow as a feature. Open tools, open proofs, open bugs. That's how you actually build software you can trust, not by hiding the attack surface, but by shrinking it in public. And while we're shrinking attack surfaces in public, let's talk about what happens when the other side is scaling faster than the defense budget. In one IDO's worm crawled across 6,000 Unix machines. The response was to create CERT, the first computer emergency response team, a single incident, a single institution. Nearly 4 decades later, ransomware claims are growing 3 times faster than the money being thrown at stopping them, and we're still building certs. There's a term in epidemiology called the basic reproduction number R0. It measures how many new infections a single case generates. When R0 exceeds 1, you have an epidemic. When your countermeasures grow linearly, while the threat grows exponentially, you don't have a security strategy. You have a fever you're treating with aspirin. One commenter put it precisely. The assumption that spending needs to scale linearly with attack growth is itself the indictment. The cybersecurity industry has become a consumption machine. Bigger budgets, more vendors, longer procurement cycles, same fundamental architecture. Perimeter defense layered on perimeter defense, each layer sold separately. Another commenter offered 2 words. Thanks, Satoshi. Cryptocurrency didn't create extortion, but it solved the one problem that kept extortion small. Getting paid anonymously at scale. That's infrastructure, and infrastructure is neutral until it isn't. The actual failure here is architectural. Closed, proprietary security stacks create monocultures. One exploit, one payload, thousands of identical targets. The organisms that survive epidemics aren't the ones with the thickest skin. They're the ones with genetic diversity, open tooling, open threat intelligence, open incident response. These create heterogeneous environments where a single exploit can't cascade. Penalizing ransom payments, as one commenter suggested, treats the symptom. Shrinking the attack surface treats the disease. And that starts with systems transparent enough to actually audit. This has been your daily tech feed for Hacker News for April 14, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go verify something you've been taking on faith. We'll see you back here tomorrow.